Hi, everyone. Welcome to another episode of Pale Blue Nexus. I have Greg Whalen, CEO of Prove AI. Greg, welcome to the show and thanks for coming on. I believe you said you're from the Boston area. How are you doing today? And what specific challenges are you facing today and what Prove AI is battling in the market?
Yeah. Thanks for having me. The good question. We're really razor focused at Prove AI on helping you get your Gen AI solutions to production. Now, that includes two things. That includes if you're building LLM based solutions, or if you're using coding assistants and trying to operationalize the increasingly complex code that's generated, right, as you're using those coding assistants like Codex or Claude Code. The gap in the market is as we've been developing, our software here, we keep coming into contact with this problem that there's really a big tooling gap, right? And the tooling gap that exists is that while it's great for getting prototypes out, great for getting us proof of value, right? There's sort of this uncomfortable gap that exists about, like, all right, how do I really run this in production without having me as a developer go back and constantly burn cycles trying to prevent drift, chase down anomalous responses, chase down inefficiencies. Like, all of these things change. It's a very dynamic system, and right, the tooling that exists in the traditional software stack for these things doesn't really apply to Gen AI. So, right, at Prove AI, we don't have a product yet. We're incubating several products in this space. So the call to action today, and what I think is interesting is it's not so much that we've solved the problem yet. It's that we have a bunch of solutions that we like, and we love to talk to people, who feel similar pain, and might want to trial some things. So very early for us, but it's a problem that really everybody talks about as a pain for them, and they would love a solution to it.
Speaking of pains, one of the things I keep hearing is that tokens are about to get more expensive. Why is that? And is that the biggest pain, or is there others that are on the top of your list?
Yeah. That's a good question, because this is very typical. It's a very near term pain, which is a very real near term pain, which is why people talk about it. Personally, I don't think it's the right thing to focus on. Like, focusing on that as a pain point is short sighted, right? So yes, I mean there's the talk of the subsidies and the facts that token prices are artificially deflated. Eventually there's probably going to be, or assumed that there's going to be, a big increase in a spike, right? And then what? Um, though what I think, though, you want to, in this space, you want to look like two or three steps beyond that and say, is this something I should really worry about long term? And come to the realization a few things, right? So one is that the models we're using, right, these token prices, right, they're very likely to commoditize, right? So when that happens, it also means that token prices tend to stabilize. I mean, will they be as low as today? They're probably still going to go up, yes. But this sort of worry that they're going to go way out of control and become some ever increasing, asset is probably more hysteria than anything else, right? The most likely scenario is they stabilize, and they stabilize at a cost that's useful to the general population. So really, your mission becomes, you should be able, your token expenditure needs to be better than average. It doesn't have to be awesome, right? You should think about this as, like, do I have the basics in place to understand where my tokens are going? Do I understand what I'm spending? Am I spending in the right place? And could I change this and tweak this, right? If the economics, right, really shifted. So it's like, that's the interesting thing to have. And then if you go through that thought exercise, what we see customers run into is to say, oh my gosh, I don't even have observability into any of these costs. Like let's start there. So yes, but again, you're thinking bigger is like, well, why are you in this position to begin with? Like, this is an odd thing. This is sort of an odd state to be in. It's like, in the traditional software world, when utility computing just came out, right? This was the same thing happened to me. This is like, deja vu. It's the whole thing was, hey, cool. There's all of these, all of this infrastructure that's on demand and I can scale and be utility priced. And then people would forget to optimize it. They would get enormous bills, and then everybody would panic. And at the same time, there was a dialogue of, well, what if, what if Amazon Web Services or Azure, what if they decided to just triple their prices, right? What's our plan for that? Right. And really, that wasn't the right question to ask. The question to ask is, do you have the right, did you build your software with the right observability in place so that, you can keep control over the systems here, right? You don't panic and assume that, compute prices would 10x in a year, right? Instead, you would say, do we, why are we in this situation? Why are we building software that we don't know how it works and we can't have any control? That's what you should be focused on, right? So like, that we recommend the same thing for generative AI development. It's like, if you're skipping steps and you're in that position to begin with where you're panicked about token costs, it's probably a symptom of you built software, you skipped a bunch of steps. You should have known better, probably, because you've done this before with traditional software. Why didn't you do it with, this Gen AI systems that you're building, right? And then it's the answer is probably because of a lack of tooling, right? And
Mhm.
that's fine. It means that you should think clearly about, like, what's the minimal tool set you'd really want, right, to control for this, because nobody wants to spend brain cycles either panicking or optimize cost. It's not worth the human brain power to worry about. It's just not a good use of stuff to worry about. But that's what I think. To make a long answer short, right? I think, yes, prices will go up, right? Because they're considered to be subsidized. Is it worth worrying about? No. Should you do something about it? Yes. If you are worried about it, yes. But the right action is to say, why are we in this position to begin with? Am I developing my software in the right way? And
What
approach it from that.
what's the bottleneck there that's causing that's not enough supply? Is it data centers?
Yeah, sure. So data centers, power, cooling. I mean, all of those things contributes to it. Hardware availability, all of those things, right? Mean that you're going to end up with high, with high costs. Some of those may or may not be resolved. I mean, but I think at the end of the day, you can only sell tokens, right? To people will only pay what they can get out of them. So it's like, yeah, tokens will go up, and there's lots of things that constrain supply right now. Some of those things will be relieved, right? If current plans materialize around data center build outs and power and all of these types of things. I mean, you should assume that those things happen. And, while prices will go up, you should also expect them, though, to stabilize, right? Which is why it's sort of like, if you, as long as you're using your tokens efficiently and you have observability into that, you should assume that they'll be priced and cost you know, at some sort of metric or some sort of value that, you know, is is reasonable, right? Because other people are going to get a similar amount of work for their tokens, and if you're getting as good or more work out of your tokens than how somebody else gets it, that's probably going to be economically okay for you.
Okay, that makes sense from the cost perspective. But I want to switch into Gen AI prototypes, and I've seen some data where like 5% of them actually reach production.
Mm.
Where does the other 95% die, and what happens there?
Yeah, great question. I don't entirely know, and that's the big mystery that we've all solved, because I've heard the same statistic. We hear it all parroted around, and then in reality, yes, if you go into some either large enterprises, medium, or even small enterprise startups, I hear the same thing. Everybody's all in on Gen AI, either for development or as part of a new pilot solution. And they changed course every 2 months or 3 months. They scrapped and threw away what they did for some nebulous, vague reason, and now they're doing something else. And that's what contributes to that 90% figure that gets thrown around. So yeah, I can hypothesize what the problem is, right? I'm not sure I fully know, because it's an open mystery at the moment. But I like to think that a lot of this is, it starts with the intent and the around what you really expected to get out of the POC to begin with, because I also don't see a whole lot of anger yet, right, about that figure, right? Nor do people who are saying, we tried a bunch of stuff for 3 months, we burned a lot of money, we failed. Now we're doing something else, and it's completely different, right? Usually you would expect to hear a bunch of pressure and anger in that discussion, and that's what I haven't seen, right? So it's not like I think people realize that there's already value there, right? That the prototype that they got was impressive enough still, right? It's mainly that when they started the exercise, there wasn't really the full end-to-end thought to get it to production anyway, right? They skipped steps, and maybe that was the right thing for them. So, like the figure itself is, it's I think there's multiple factors that go into it. Like one is just the initial intent maybe was never really to do that, right? The initial intent was, can I get value out of this, and then we'll figure out what's next. So the figure is more alarming than it really needs to be. Part of it, though, is for the ones who did develop something, right? The fact that you start to see value and start to see something that looks done, looks 80% done. The problem is you've only done 20% of the work, right? And that's very different than traditional software, right? Software, it looks like unusable mess until it's almost done, right? And with generative AI, it's flipped. So either whether you're using coding assistants or whether we're talking about an LLM-backed solution, you get something that's like, oh my gosh, this amazing. I'm amazed it got this far. And whoa, can we just productionalize this? The thing is that you're not comparing apples to apples, right? We're comparing things that aren't comparable, right? Because really what this prototype was really only represents a 10 to 20%
Right.
done thing that people are walking away from. So again, the anger level is going to be different. Um, Sure, it didn't make it to production, but you didn't really build it. You built something that's far, far smaller. And in the traditional software world, this wouldn't even have been talked about, right? So it wouldn't have ever been part of a statistic like, nothing's getting to production. So that's part two. Part three, though, is an area that is worth focusing on, and this is where Prove AI helps. And this is that, right, when people do develop and find something of use, and they get it to close to production, they find a massive tooling gap, right? So they realize that you're going to need to spend time to you know, update the software. You're going to need to make changes to it. You're going to need to do all of that without regressing behavior. You're going to need to, have visibility into what things are going off the rails, right? And all in such a way that you can't have to spend your entire day on this, right? That's the key thing is that, right, engineers need to move on to new things. And what they're stuck with is a situation where they're like, it works, it's great. And then they realize that as people start using it, they wake up with their morning coffee and they go on, a 4-hour side quest to go and investigate 6 failed conversations, like 2 odd tool calls, right? And then it's 2 p.m. and they're sitting there saying, man, this is not normal, right? Engineers you're supposed to be done and move on, right? Operationalize, handoff, move to a DevOps team or an SRE team or something, some sort of on-call rotation, and that's where people get stuck. So then it's like, well, why is that stuck? It's because there's no accepted procedures in place for how to handle this situation. There is no tooling. You probably have to build the tooling yourself, right? And these are the things that it means that you're stuck, and half your day goes to supporting something that you thought you would just get for free, right? Because you've always gotten that for software, especially
Right.
if you're an engineer and you're in your 30s, right? This is stuff that you're used to just getting out of the box, right? You know, oh my gosh, yes, we need alarms, we need all of this stuff, we need run books, we need all of this stuff, and it's just like, yeah, those things are not a big deal anymore. If you go back to the 90s or the early 2000s, it was a big deal, right?
Yeah.
That was all big discovery. So we're in the same pain point again, where people are like, oh, I assume somebody solved this, and then they get to the point and like, wow, there's nothing out there for any of this for Gen AI.
I talked to some engineers yesterday at a meetup, and basically they said like it gives you AI does has this thing where it gives you a amazing confidence, right? Like it says it's great and all these things are whatever your input in, great job. But you're saying that there could be like a silent regression in your workflow that basically is setting you back, and you need to get granularity on that. Is that what I'm
Yeah.
hearing?
Yeah, so that, and then on top of that, the fact that you're dealing with a non-deterministic system that, like, you can't test for every possible
Right.
outcome. So, Like, when you open it up for, the use cases that you can think of, and you think you've designed test cases for them, um, context can change, data assets can change, right? And everything can go south very, very quickly. And this doesn't happen with traditional software. Yeah, and that's the key thing, right? You think you have test coverages and alarms in place, and then a bunch of things happen, and you get surprised that you're really nowhere. You were never actually near done to begin with, right? Even if there's the regression problem you just talked about, right? So yeah, over time quality degrades, but then on top of that, there's still the whole, yeah, you were never done anyway problem that people are avoiding.
Interesting. And could talk specifically about where your suite of tools fit in, and what specific products that you're releasing to fix these things.
Yeah, sure. So we have a bunch of ideas where we're incubating. For some, they're vertical focused. So I'll make a caveat in that we're looking forward to a situation like our tooling and our products are forward looking to a state where engineers are primarily removed, mostly removed from the implementation details of what they're building, right? So we assume model quality gets better. We assume that there's a natural evolution to how good, the types of tasks that they can do, which also means you end up with engineers who are less inclined and less able to hand tweak and hand manage the stuff that's been built. So if you go on that mental exercise and say this problem of visibility and is going to get worse, right? We focus on, well, how could you manage this complex system of multiple agents, some of whom might be building for you, some of who might be fielding questions from customers or taking action based on customer stimulus. Like if you had to manage 10 of them, and at some point, you become so removed from the details that you can't really intervene and hand fix anything yourself. What would the workflow and what would the tooling look like to control for this? Like, how would I get visibility and observability into that stack? Like, what would be an appropriate way? Because you're not talking about a graph anymore. Like, you're not talking about a nice, pretty graph that with anomalies and investigations, because at that point, it's going to be meaningless. You have no idea what a latency graph is going to tell you at that point. Um, in terms of like, controlling things, right? You're not going to be able to instruct your agents with technical controls anymore because you don't even know how it was built, right? And you don't care, right? And that's great, right? That's where I would expect everything to go pretty quickly. So at that case, though, like, I draw the analogy to somebody who's been like a technical leader, and it's like, when you're supervising a team of 100 technologists, and you need to keep them making high quality decisions. You have no idea what they actually built though, and you have no idea how it works, right? And that's fine, right? That's part of the job, right? But the hard part of that job of being a senior, a very senior technologist is teasing out ways to ask the right, questions, build the right mechanisms to enforce good decision making amongst your employees and now your agents, right? Without having any idea of how the thing was built in principle. So if you sort of take that philosophy, we say, well, what would a tool look like if now I want a tool that basically managed my 100 agents just like I would manage a team of 100 developers? Like, what would that tool look like? Because that's an interesting tool. That's not something that looks like a dashboard with a bunch of stuff. It's not a graph. It's not it's not a list of anomalies and things to investigate, right? Because the same problem. If I'm a senior technical leader, I'm not going to go and, if I have a team of 100 or 500, I'm not going to go in and say, oh, cool, I found the anomaly. Let me go push a fix. I would do more harm than good, right? Because I'd probably break things that, I didn't know about. So I mean, so we're looking at that overall problem, and then to be more specific, we're looking at three personas. So one is the AI engineer who is really focused on the edge, right? They're on the spectrum right now. They're far over into being all in on, like, building with AI, with Gen AI, as well as developing Gen AI solutions. And really, we'd love to talk to individuals who are like, really spinning up many agents, right? And have an aversion, or realize that they can't hand manage their workloads anymore. And they're starting to say, how would I manage this system of stuff that I'm building? Because it's super useful. I'm getting so much done as a single person or as a small team, right? But really, I can't hand manage this anymore. Like that's specifically the type of people who, we'd like to talk to on the tech side. We do also though want to talk to people in the legal profession or in the finance professions. So we have a couple of products we're incubating for people in financial services who use Claude Code or equivalent to help them build or maintain financial models. Right. So it's an analogous problem. It's like if you're going to set, if you're a finance person and you want to use agents to do some of your modeling work and you want to instruct them, right? How do you put in enough controls for those agents so that they don't do a few no-nos, right? So that they don't do things like violate compliance rules, that they don't mess around with a
Right.
formula that's forbidden, they don't pull financial data from the wrong source when told otherwise. Like think of it as analogous to managing a person, right? It's like I don't really care how they do the work, but don't you dare do this, right? And it's an interface thing of number one, how do I express that to the agents? How do I observe it? And how do I realistically control for it? The reason why we're interested in the finance space is because it's a constrained development environment, right? It's not as big as the overall population of AI engineers, right? It's something we can realistically solve now because we're talking about the development of macros and formulas, which are technically easier to control for than any type of software. So we're interested in that. And on the legal side, it's an analogous problem, but to legal, right? So if I'm using generative AI to refine and to create things like contracts, again, how do I control it for I want it to help, but how can I put a safeguard to make sure that when it let's say proposes a Gen AI generated clause change, that I'm not accidentally diluting the power of my contract, right? This is especially prevalent if you're a team of lawyers who have to work together, right? So basically, if I'm a legal professional and I have my agent, right, somebody else is making revisions, they have their agent, you get into a very tricky observability loop here where it's like who's changing what and why did they do that, and why did they change text from something like you know in clause 5-3, right, to in the clauses above, right, which is one of those things that a Gen AI thing might do and say, oh, this looks like a good generation, but start to really make some subtle but dangerous dilutions to your contract. For doing it one at a time and here and there, it's not a big problem, but you can imagine scale it up, scale it to the point where there's multiple agents and multiple people. You can imagine you're going to step on yourself very quickly, and the existing tooling that's out there doesn't really work very well. So I'll
Yeah,
focus
and
on
even
those three things. That's what we're incubating at the moment.
amazing. I think this is so needed. And also like even to a more basic appeal to startups and people like that, they definitely care about cost. So I figure like cost management might be part of your tooling as well. Like
Absolutely. Yep.
I
So
don't know,
cost is
like
something you get out of it. Yes. So you get cost
context
control out of it. Yeah.
optimization, like context optimization, 62% of just context just keeps churning back in, right? Like, do you have something for that?
Yep. Absolutely. So that's part of our that's one of the value propositions in the tool that we're using to help bring observability to that single developer, managing multiple agents. Absolutely. It's part of that is the observability of like, well, what am I feeding to different parts? Depending on the workflows and depending on the paths, is this really optimal? And then the interesting thing that we do differently is to say, okay, and even if we find the problem, let's assume that you as a human being and an operator cannot fix it yourself, right? Because you're going to at this point, you're so removed from the details that it's going to be great. It's giving itself the same context and it's wasting tokens. What do you want me to do about that? Why do I, as a human being, need to fix that? Why can't you fix it, Claude Code or OpenAI? And then it's because agents need instructions and there's multiple agents involved typically, and they do all sorts of things. So then it begs the question of how would you realistically implement that cost control once you've discovered it, without having the human being, the operator, be tasked with doing this work, right? Because that's annoying in today's world for most people. It is unscalable and impractical by next year, even. So that's why we focus on that. Yeah.
And you call it like a coordination tax, right? Like you have a multi-agent system. It's routing, but then queries can be sent between each other, context can be sent with to each other.
Mhm.
And then finally, I guess they would return different results. How do you determine which one's canonical and things like that?
Yeah, yeah. So exactly. So you get this coordination tax, and as you scale up your agents, and you say, "Cool, I have all of these things, and they're doing well." Just like a manager, just like a senior leader in a company, you end up with, a bunch of additional work that gets thrown at you because things that do work and don't communicate all the time start to push things, start to do things that are suboptimal. So I mean, it depends on the use case. I mean, in some cases you can control this just by looking at paths and things like that. We've looked at some ways of sort of controlling for this, and in our prototypes here we have a few hypotheses that we can test, right? But some of them are interesting. Think of it as exactly how you'd manage a human being, like again, saying that the path maybe or maybe not does not matter, depending on the case, or depending on your application. But maybe you want to be absolutely sure that the core facts being used are always invariant, right? And that's what you observe, inspect, and right, you make sure that you have controls in place for, right? But okay, but then how do you build all of the tooling to periodically probe your models and say, hey, what are the core facts you're using? What are the core facts you're using? And measure that drift, right? That's the tool that's missing, right? So that would be, again, something that we're incubating, at the moment, right? It works great for some. Works great for some use cases, but that's an example, right? To put that into a very real world thing, right? You can, maybe you don't care how a team of cleaners, right, gets their work done, right? But you are going to have a few inspection points, right? And say, all right, well, I want to see, like, maybe the mixture of your cleaning fluid is something that I actually do inspect, right? Because that's something that, like, if, it's pretty easy to understand and measure whether a floor has been cleaned. It's pretty, easy to then say, did they use the correct mix of cleaning fluid? If both of those things are always accurate at the same time, and you're sure that somebody's cleaning and there's a proper mix of cleaning chemicals, maybe you
Yeah.
don't need to worry about the rest, right? So the analogs are, yeah, they're fun, but they roughly scale to this type of thing. It's just picking the right thing and observing it is tricky, and that's the tooling gap.
This 100% reminds me of when software engineering was becoming an accredited practice in universities and institutions. There needed to be formal verification for it to be called an engineering practice.
Mhm.
It sounds like AI engineering is going through the same life cycle right now. We need to have proofs, right? And
Yeah.
yeah, are you agreeing
Well,
with
proof
that?
or some assurance. I don't know how
Yeah.
it will. I don't know how it will unfold, but again, this is again one of my, almost the way that I got pulled back into the area is that, as there's multiple parties who are working and consume each other's AI services, right? I want to know, well, this AI service I depend on from another vendor, like, how do I know that, one, it's doing a good job, right? What are the outcomes? How do I know that everything's above board, that it's consuming data assets it's supposed to consume, right? And how do I know that the mean of how it does its work is acceptable to me, right?
Right.
There's not a good way to exchange that information. The SaaS world sort of took the easy way out, right? The SaaS world was like, look, it's just too hard. We'll do SLAs, we'll have contracts, and we'll give back money when things fail,
Service
right? And yes,
credits.
if there's and we do audits, right? And we have things like SOC 2 and we have ISO certifications. But basically, that was how we established trust between a party with software and a party who wants to consume the software. That doesn't work for Gen AI. That's the problem. So we would assume so working from the bottom up is, yes, me as a developer, I need to have assurance into how my practices are, but we can assume that there's a longer term state to, okay, and how do I transmit or communicate this to the people I work with, and or work with a third party auditor or verifier or whatever who knows what's going to happen? Who certifies that my AI practices are indeed in line with the industry? So yeah, the prediction, I can't actually predict what will happen here. I would expect something to happen, and I would expect it to be different than how software is managed today. Because in today's world, it was just really it's latency, error, right? And availability, right? And I want to know those three stats. I'm going to create a nice, tightly worded contract around them. I'm going to audit, I'm going to rely on third-party auditors to accredit that practices are being followed, and that's enough for me. It's just, yeah. If you look at AI, there's no way that is going to just work, right? There's going to have to be a lot more.
I mean, I could see like the major thing today is compliance and regulated sort of proofs, right? Like there's a lot of things that need to be shown when you get up into enterprises and things like that. So starting at the base level when a startup is first starting makes total sense.
Absolutely right. So, and that's the idea is if you build a frame, you build a ground floor today, because what like talking about risk and talking about compliance around AI today is still a bit premature,
Yeah.
right? Because it's just going to beg the question of, okay, well, can you observe like, how are you going to comply if nobody actually knows what's happening, right? So solve the observability problem first, right? Figure out how to manage your AI systems. That's going to be something you have to do anyway. Whereas, talking about it from a regulatory top-down perspective is, probably counterproductive at this point because, it's just going to turn into well, let's talk about what we can do today, and then you end up doing the bare minimum, and that doesn't benefit anybody, right? And that again, there's analogs to traditional software, right? So the same type of things. There were, a few choice laws that came out, right? And it sort of created a spur of very localized activity in software. But like when you do things top down, regulatory like that, it incentivizes bad behaviors, right? Incentivizes people to do the minimum, right? And in this case, that's not right what we want to do. We want to encourage people and to get working software out to be stuff that it's sure of, and that starts with building a very good ground floor with observability and control of your systems.
You talk also about the necessity of having a human in the loop, but that from what you're talking about today, it sounds like it's becoming less and less of execution and verification and everything like that. But where does that net out? Like where does a human slow things down? And I think I know where you're going with that. But where is it absolutely necessary?
Yeah, yeah, sure. So, I mean, when we say the human in the loop, right? It, like any system that is built, right? You still want to have and will need to, the assertion here is that you still need a highly skilled operator to run and right, to make sure that everything is going as you wanted it to, right? So the point of that is really there's not don't anticipate there's going to be a magic, you know, um, sort of a AI revolution here in such a way that it can understand what you want to do,
Yeah.
what it should be doing in a case that has never been done before, right? So you're building something brand new. Yeah, there's always going to be that knowledge gap or that intention gap. So like, expecting Gen AI to do everything is a pitfall, right? It's something that people go, it's just like, nah, like, why can't it do that? And at some point there's a wall, right? Because you're doing something that's never been observed before, that is not in the common body of knowledge. You don't have anything to teach or to train your AI. So how why would it know the answer to that, right? It can't read your mind. You're the only as the person developing it, you're the only person who actually knows this. So thus you need to do something. um, the big gap is just getting distracted by stuff, right? It's not spending time on the things that you should be spending time on, and it's not having observability into the
Right.
things that you need to observe. And why is that? And it's just because there's figuring out how to manage and what exact question to ask, and then how to once you're sure what you want asked, how to organize that and how do you as a human being consume it, right? Those are the gaps. Those are the things that don't exist as tooling. So you end up building stuff yourself, right? It not being great, and then ultimately giving up and saying, well, it kind of works, and I guess I'll just fly partially blind, right? And that's the pitfall.
And I guess when we're talking about this level of production, we're talking about transactions being made. Eventually,
Mhm.
there will be agent to agent economies, and
Exactly.
you're talking about maybe billions or millions getting settled by agents themselves. How do we get there? Like, how do we trust agents with real money? And
Mm. Yeah. Sound like a broken record. Observability is part of it. But also I think the key thing here is around like for financial transactions and things of that nature, like when there's money being spent or work being done, right? Outcome measurement, right? And making sure that we understand the full actions that are being done, the chain of actions or that are being done, and we actually have real-time feedback loops from these transaction chains is going to be super important. Again, that's something that doesn't hasn't traditionally existed in much of SaaS software. It's very much my stuff does this. We have an interface. We hand off to you. You have your own metrics. You hand off. Obviously, it's not true in every case, but in most cases, that's sufficient. The thing to focus on with things like financial transaction and when risk becomes more important, right, is that if I don't have a good way to measure and understand, like what are the downstream outcomes that are really happening from the actions we're taking, then right, then that's the big, gap here. Um, yeah, so like that's different because we don't really have the mechanism or the toolings in place to really collect this from, let's say, from a chain of agents from multiple vendors, right? It's like they're just going to say, "Look, I'm done with my job. Here it is," right? And you end up with perhaps really bad outcomes. And to get there, the first thing you need is a coordinated way for these agents to, right, either themselves collect and distribute like what the goal was, what the goal status was across the chain, right? And then probably make that verifiable cryptographically at some point, right?
interesting.
Lots of ways to do that. But the analog we did some design partner work or some early stage work with people in food inspection, right? So there's a great analog here. It's just like sure, if one person sells machines to inspect food, and then you know the food producer inspects stuff, right, and they use those machines, and then there's somebody selling the food, right, at a supermarket, etc., and somebody gets like a piece of metal in their food, right, then it becomes all right, well, we all had coordinated tasks to do, right? How do we go back and now replay this and understand what happened? In today's world, right, or at least maybe in yesterday's world, it is a very slow process, right? You have to go back and say humans have to get involved, and they have to say, all right, everybody, pull your logs. What happened, right?
Yep.
Let's have a weekly meeting about it for the next 3 months until we get to the bottom of this, right? The point with agents doing this work is you can't do that anymore. They're going to have to resolve this themselves, and they're going to have to do it in near real time because you know the the potential blast radius of the problems is too big, right? So that becomes the never before solved problem, but it is analogous. It's stuff that we do today with software systems. We're just way too slow. We spin up a meeting about it, right? So company A gets on the call with customer B. They do a root cause analysis, right? They threaten each other with lawyers and tersely worded emails. Yeah, that's what needs to go away. And that's exactly the type of tooling that doesn't exist, right? There's no infrastructure to do any of those things today. But that's the activity that will have to happen instantaneously in near real time, right, in order to get to those financial transactions happening between agents.
Yeah, I mean, when I was at JP Morgan, I was very much into Splunk and decoding logs, and I think that's what you're saying is like we're getting to the point where we need to create the logging system for AI.
Yeah, absolutely. Yep. So the logging and observability is the thing, and it's just tricky because one is figuring out what to log is harder. And then secondly is how do you prepare for the eventualities of sharing that log with other people who may or may not be humans? They might be other agents, right? That's where people get stuck. And they're just like, this is too hard. Let's skip it. And that's the problem, right? That's why you end up with systems that sort of work or deceptively look like they work, but are brittle and not easy to scale.
I want to thank you so much for coming in today. This was extremely enlightening for me as an engineer, and I hope to keep in touch with you and share what the progress of Prove AI.
Likewise, yes. You can check us out at proveai.com. We have some thought leadership at proveai.com/blog/PDD. And then, yeah, as I said earlier, like we're not in a position yet to sell. We do have some early stage design partners. If the problems I've talked about resonate with any of you, just get in contact with us on at proveai.com, and we're happy to demo or talk about whatever we're working on. So thank you. Yes, and thank you for hosting.
Welcome.